So hello friends, welcome back to Suraj Ke classes. So we are here with one of interesting video again. So this video is for differentiating or to make your doubts clear regarding AC and DC. So we would quickly start with the alternating current. Then after we will go for the direct current or the DC. So firstly, I would like to show you that we have already discussed regarding this. This is one of the AC supply that is coming at your home. It is having standard voltage level of 230 volt and standard frequency that is of 50 hertz. We would like to go into the details of both of these quantities. What is this voltage and what is this frequency, and how this is different from what you have, that is your DC supply. How this quantities are different in of DC. Firstly, we would discuss for this AC. So see, one of the some more quantities of AC that you might have encountered while browsing some of the electrical appliances or some of the details of this. So you come across these quantities like some main quantities I would like to highlight here. This 220 to 240 volt. This is actually nothing but first thing, the voltage level. The voltage level for which the particular equipment is designed for, or particular equipment is designed for operating, the operating voltage of this equipment. The second thing that you will notice here, that is your frequency. Okay, the frequency you notice here, that is given of 50 hertz, means this LED bulb that is designed for operating on 50 hertz frequency. The third thing that you will encounter here, this is the ampere rating. This is nothing but your current consumption of this particular equipment, the current consumption of this particular equipment. The fourth thing that you will encounter here, this is nothing but PF. PF means P stands for power, F stands for factor. So this is nothing but your power factor. This is what? Power factor. So I hope these things are clear to you now, that what this voltage, frequency, current, and how these are indicated on particular electrical appliance. Okay, we would like to go into details of this, that how these things are coming. So this is a broad view for you, that how these things are looking. We would discuss on four quantities, that what is voltage, what is frequency, what is current, and what is your power factor. So firstly, one by one, first thing, that is your AC. We will start with the AC. AC again, AC, where A stands for alternating, A stands for alternating, and C that stands for current, where A stands for alternating and C that is nothing but your current. Okay. So I hope this AC term is now clear to you. Now this term is itself defining itself. Okay, this term is itself defining what this AC is. Okay, alternating means nothing but not fixed. It's in alter in nature, not fixed. Okay, current means you very well aware that current is nothing but the electricity that is consumed by your particular appliance. That is in layman language. I am not going to the detail, but current is simply defined like that: the electricity consumption of your particular equipment, or the electricity requirement of that equipment, right? So what is this AC now? Why it is being called alternating? Why it is being called alternating? And where however, if you see the DC, where D stands for direct and C stands for current. So these both quantities are actually different. So why this AC is being called alternating and why this DC is being called direct? So we would look at both of these parameters now. So I will show you one graph here. This is a graph. Okay. This axis is for voltage and this another axis is for time. Now if you see the graph of the AC voltage, that comes like this. This comes like this. Do you know what these parameters are? Do you know that? So these parameters are nothing but, this is actually pi, which is 180 degree. This is 2 pi 360 degree. This means one cycle. If I'm going to crop this single cycle, I'm going to crop this single cycle and explain it to you. So I'm again drawing this into a single cycle, and this is now 0, this is now pi by 2, this is now pi, this is now 2 pi, right? So this is one of the single cycle of AC voltage or AC current. This is what? This is the cycle of AC voltage or current. So this graph would clarify two of your doubts. One is of voltage and second one is of frequency. How this is going to give you the clarity, now I will explain you. See, this one cycle or this one cycle, the total cycle, the time period it is taking, that is of 2 milliseconds. What that is? 2 milliseconds. Means now you would think of where is this, that 230 volt, okay? Where is this 230 volt in this graph? Where is 50 hertz in the graph? The both of quantities I am going to reveal out of this graph, and let's understand how this happens. See, this peak voltage, this is actually a peak voltage. This is rising from 0. That means your voltage is getting, risen from this 0, and very gradually it is coming to 325 volts. Now you will think of why this is 325 volt. Previously we discussed that this was 230 volt, right? I will explain you everything. This is actually positive cycle. This is positive period of the cycle. This is now completing 1 millisecond. So this operation is happening in milliseconds. You just think of it that how quick your electricity supply coming at your home. So the entire operation is being done or being completed, the one cycle, that is of 2 milliseconds only. So here one cycle is of 2 milliseconds, and this half period of the cycle, that means one term, that is of 1 millisecond. Okay. So in 1 millisecond your voltage is rising from 0 and then it's coming back to 0 again. This is nothing but 0. Okay. Now it is going negative. This is actually your negative cycle, and it is attaining, the magnitude is now minus 325 volts. The magnitude is actually getting positive, 0 to positive, 0 to positive, then positive to again 0, then 0 to negative, then negative to again 0. So just think of it that in 2 milliseconds only it is crossing 0 2 times. It is crossing 0 2 times. How these 2 times are happening? See, from 0, if you are counting 0 t plus time, from 0 t plus time, then it is not 0. Then once it crossing 0, then again at the end of 2 milliseconds it's again 0. Then again the second cycle comes, then again it is. So in 2 milliseconds only it is crossing the voltage is coming to the 0 2 times. Okay. So write down this point, the voltage is 0 2 times in 2 milliseconds. Per millisecond this is getting 0 1 time. The second thing that we are getting this from graph, that this voltage level, the peak voltage, I am writing this here, V peak, it is nothing but 325 volts. Now see, that at your home, the voltage level that you are getting, it is 230 volt. Whether you are measuring it on your voltmeter or multimeter, it is showing you 230 volt only. So let me clear you guys that this 325 volt is just peak voltage. The voltage that you are getting at your home, that is VRMS voltage, root mean square voltage. It is coming from this formula, V peak upon root 2. So VRMS is equal to actually Vm by root 2. So if you are calculating this VRMS, V peak that you are putting here 325 root 2 1.14 1.414 something like that. So this will give you around voltage of 230 volt. So this is how your 230 volt is calculated for your home. But the peak voltage that you get your home, that is of 325 volt. But whether you are using your multimeter or you are using your voltmeter, that would show you the quantity in terms of VRMS, and VRMS is nothing but that is your 230 volt. I hope this fundamental is now clearing your doubt about the 230 volt. So V peak is always 325 volt, but as we are following the standard in RMS, actually RMS is that is a different thing. We will discuss it later on. Actually, it is compared with the DC, that the conductor taking the amount of voltage for heating up the conductor, the amount of voltage that is required in terms of DC. Like in DC, 230 volt is required to generate that particular heat. Then here in AC, 325 volts are required. That is why the RMS is getting converted in that term. So that is a different scenario, different chapter. We will not get into that right here, but in some other video definitely we will look at it. But the one thing that is now clear into your mind, that the 230 volt, how it is coming, what is the waveform, the same is applied for the current. Okay, the same is applied for in terms of current. The current is also following the same type of waveform, that is also alternating in nature. So one thing that you need to remember, that this AC, the AC voltage, alternating voltage, is getting 100 times 0 in 1 second. Okay, in 1 second there are 100 milliseconds. So per millisecond it is crossing 0, then 100 times it is getting switch on and off. But you will not feel it when you are when you are supplying your LED bulb or supplying any of electrical appliance. So that time you will not feel it, because in 1 second 100 millisecond times 100 times it is crossing 0, then it is nearly constant. Nearly constant means you will not feel it. So it is very micro level of change. So that is not being considered, or that is not being in your electricity device. You will not able to see it in your your eyes are having not that capability to observe that much frequency of changes. So that is a different scenario. Now we are coming back to the frequency. Now what is this frequency? Now we are coming back to the frequency. Again I am drawing this graph. Okay, so it is actually 0 and it is actually 2 milliseconds, and it is your time frame. This is your voltage frame. Now see, the frequency is nothing but number of cycles in 1 seconds. Whether it's a voltage cycle, whether it's a current cycle, the number of cycle in 1 second. So the number of cycles that you are getting in 1 second, so see, number of cycles you are getting in 1 second, if 1 second is converted into millisecond, it's 100 milliseconds, and 1 cycle that is of 2 milliseconds. So if you are dividing this, then you are getting the frequency that is of 50, and the 50 is having unit of hertz. The 50 is having unit of hertz. That is why the frequency is being called in AC terms, that is of 50 hertz. I hope the both of the concepts are now clear to you. The one concept was of the current and one concept was of the voltage. So out of these two, so we here wrote down the voltage concept is now clear, the current concept is clear, the frequency concept is also clear. One concept is remaining, that is your power factor. So this is your power factor. This is written Here power factor is written 0.90. Now, before going to that concept, I would like to tell you about more about AC. More about AC, but before we go into that, we will like to have some discussion on DC first. So now let's go to the DC. So this is one of your charger. I have shown you. This is one of your charger. So this is nothing but your mobile charger, right? This is your mobile charger. And if you see the details mentioned here on your mobile charger, we will also zoom it in. Don't worry. So this is your one of your battery. Okay. There are two polarities, positive and negative. There are two polarities in battery, positive and negative. As well as in charger, there are polarities. Like you see the this C-type charger or micro USB. So there are terminals inside it. One is positive, one is negative. See. So these terminals are connected to your mobile battery, and that is how it works. Okay, fine. Now let's go into the detail of this charger. So I have just zoomed out in that these details. See how many details you get here. Let me zoom it in for you. So see, the mobile charger is having some details. See, input is AC. Okay, the input is AC 150 240 watt. Actually, mobile chargers are designed globally. For global market, it is designed. It is not that the charger ratings are to be changed as per the country. Actually, this charger is valid for India, as well as if you are traveling abroad, like you are going into America, then also this same charger can be worked on. So the frequency level is different. So the frequency level is also mentioned here, 50 or 60 hertz. So whether you are operating it on 60 hertz, it will work fine. There would be no issue, absolutely no issue. But the voltage level can be, issue here. This is 150 to 240 volt. But in many of the chargers now it's coming 110 volt also. It is also capable to operate on 110 to 230 volt. So that would won't be an issue there, right? So this is one of the rating of the charger, and the charger being operated on 3 voltage. So this charger is actually multiple voltage level charger, but generally the voltage level that we are getting, this is 5 volt only. Okay, the chargers are operated for the output voltage of 5 volts only. Now let me show you the graph of DC, how this DC is working now. This is your time frame and this is your voltage frame. So when you are working with the DC, it is very simple. There is a single line only. There is nothing else. So there is a single line only. So this is your DC. If you are taking it for your charger, then 5 volt is coming here. This is nothing but the magnitude of your voltage. So magnitude of your voltage is 5 volt. The magnitude of your voltage is 5 volt. So this is a simple graph. There is a single line. There is no other quantity involved. There is a single line. This line is not going to vary at the infinite range of time. Like in 2 milliseconds, you observed that the AC was getting into 0 in 2 milliseconds. It was crossing 0 2 times, but it is not going to cross 0 anytime, whether you are working it for 1 hour, 2 hour or like lifetime. So it is not going to get 0 anytime. So the charger magnitude remains constant. That is why the term has been defined like DC. D stands for direct. That means the supply is direct. There is no alteration in this supply voltage or supply current. So this is very simple. I hope there is no other understandings are required. So this is there is no frequency involved, because frequency, that is a term, that is a number of cycles per second. Frequency is defined like that. So there is no cycle. So the frequency term is going to be 0 here. So, same way some other terms are also going to be nullified in this, like power factor is not present in here. Like you will have some other forms also, reactance and inductance are also not applied to this DC. So this is actually very simple form of supply, but still why we are not going with the DC, why we always are comforting ourselves with the AC only. So we are coming to that point only. So before discussing that point, this explanation was very necessary. That is why I have showed you this slide. Now let's come back to the AC. We were here that AC is having voltage like 230 volt. It is having 50 hertz supply. It is having current that is also having 50 hertz, in nature. frequency is 50 hertz, and it is alternating in nature. Now why AC? So this is a big question now. So why AC? Why everyone wants AC? Why AC? This is a big question mark here. Even though the DC is very simple, there is no frequency, there is no reactance, there are no complications. Then still, why we are not using that DC? One video that I showed you in previous my videos, if you browse, then you will come across one video that is on transformer. What is transformer? What is transformer? What is inside? This is one of my video. If you go through my channel, then this is not a very old video. This is like 5 or 10 videos previous. If you browse, then you will find this video. What is transformer and what is inside? So this is very good video. In this you will find a very important concept of transformer, and this would also clarify many of your electrical doubts. So you just go through this video. I will recommend this to you. Go through this video. Okay, this will also clarify. Anyways, I'm also going to clarify the doubts of AC here. Why AC is used? Why AC is used? So I'm also going to clarify the doubts why AC is used. Why AC? I'm going to clarify this now. See, your transformer that works on principle of mutual inductance. Okay, just forget about transformer. We will first go with the why AC. We will first go with your electricity supply structure, how that electricity is coming to your home. Okay, let me clarify that to you first. So at your power plant level, this is your power plant or your powerhouse, right? Power plant may be in term of this may be thermal plant, the coal based plant, like the coals are heated, there is a boiler, and when boiler is heated up there is a vapor, and vapor is pushing down your turbines, and turbines are rotating your alternators, and alternators are generating the electricity, and this is the ultimate way to get the electricity. This is the principle of thermal power plant. There are some other power plants like hydro power plant. The working of the hydro power plants, like there is a dam, and dams are connected with your turbines. There is a flow of water, and that flow of water strikes your turbine. Okay, if the turbines are rotated, alternators are rotated, you are getting the electricity. There are some other forms of power plant also: nuclear, tidal, solar. Okay, so these are the form of some major power plants. So these are major, like wind power plants. Wind power plants are also nowadays very trending. So this is some of the power plant, the major or the famous power plants. Coming back to the point that these power plants are having some voltage level of electricity. Like let's say it is generating 11 kV of electricity. 11 kV. I already told you that what is this voltage level. Okay, so 11 kV means 11,000 voltages it is generating. So the 11,000 voltage that is coming to you from your power plant. You know what happens next? These power plants are connected with some transformers. The power transformers are installed outside the power plant. The power transformers are installed outside the power plant for converting this 11 kV to 33 kV, 66 kV, 110 kV. Okay, so many more, like 750 kV or around 700 kVs. Okay, 732 kV maybe. So this is types of generation from 11 kV or whatever the incoming level of voltage that is coming out of your power plant. So this is your first step of this is called in technical language stepping up the voltage. Step up voltage. So the voltages are step up and current is step down. Current is step down, obviously. The principle of a transformer, that is V1 I1 is equal to V2 I2. Voltage into current is equal to voltage into current primary, voltage into current secondary. So this is the principle of transformer principle. If you are stepping up the voltage, then your current is getting down, because power has to be constant in any case, in any condition. The power has to be constant. The voltage is low here, current is high here. This is your primary 11 kV and this is your secondary 132 kV or 66 kV, whatever, right? Here current may be of 1000 amps. Here current, I'm just taking an example, I'm not going to the practical detail, but let's say if it is 1000 ampere, then here it may be 100 ampere or 150 ampere around. So this is actually, I'm taking a case, I'm taking an example. So this is what happens at the outside of transformer. Okay, now let's move into the next stage. This is your power plant, PP, I'm considering power plant. This is your distribution transformer, DS, right? And now it is being stepped up. There is a distribution network. This may be of 10 kilometers, this may be of 20 kilometers. The power stations, if you see from your house, the power that is coming are coming from very far away. Like these power plants are located at a location where there is no disturbance. Like if you are installing a thermal power plant, so it is actually contributing some pollution to the atmosphere. So it is being installed at a place where there is no residency around, or less residency, so that people get affected less. That is why these transmission lines, this is called transmission lines, are very long in a way, like 10 kilometers, 20 kilometers, in some cases 50 kilometers, 100 kilometers. Sometimes it is also sharing the borders. Like if you are living in Gujarat, then Gujarat electricity or the Gujarat power plants are supplying Haryana, Rajasthan, Madhya Pradesh, or maybe it is supplying Uttar Pradesh. So these lines are very much long. So 100 kilometers, 200 kilometers lines are there. So do you know what happens if you are supplying this 11 kV to this long distance? Then your output voltage would not be same. It is very difficult to transmit the output voltage. Why? Why this is that? Do you know why? Because your 11 kV is having the current level very high. If the current level is very high, then conductor are to be designed to be very much in diameter. The diameter of conductor is very much. I mean, diameter of conductor is more. Diameter is very big. Bulky conductors are to be installed for supplying that electricity. And again, the voltage drop is going to be there. You are not going to supply. This is not practically possible. So if you are generating a DC here, just think of it, then you are not able to supply it for a long distance. So that is why DC is failed here and AC is successful. So this is one of the reasons why AC is widely used and DC is not widely used. So this is the limitation of DC, and this is the major advantage of AC, that you can easily, by transformer, you can step it up from 11 kV to 132 kV. You can step up and you can transmit it for long distances. There is no issue. There is absolutely no issue. This is one of the major advantage of transformer. The second advantage we can count here. Okay, before the second advantage, we will come into the one of the more factor. Okay, we discussed here. See what we discussed here. So I hope this is now clear why we are using AC. This is the major advantage, that for transmitting the voltage for long duration. And secondly, not only for transmitting voltage for long duration, the second advantage, when you are having at output side 132 kV, but 130 kV is not useful for your home. What you required at your home, that is 430 volt. Okay, then 132 volt can be easily stepped down to 11 kV, and 11 kV can easily be stepped down to 430, 415 volts. And from 415 volts you can easily get 230 volts. So it is very easy to change the voltage levels in AC with comparing to DC. DC you cannot change. Of course, there are devices used for converting the DC levels, like choppers are there, but choppers are not that much of reliable. You cannot install chopper everywhere, and it is very difficult to maintain the choppers. There are many other parameters which are coming to play the role, like harmonics would be there, DC ripple would be there. So there are some drawbacks where choppers are not useful. So that is why for conveniency it is very convenient to use the DC. You know the transformer efficiency? Do you know the transformer efficiency? What is this transformer efficiency? The efficiency of transformer around 99%, more than 99% efficiency it is getting operated. Okay, so transformer is very useful device. That is why transformers are used. Well, going to the next point, power factor, that we already discussed. What is this power factor? Power factor. This is the parameter that is relevant to AC only, for AC only. For AC only, for AC only, this parameter is used. For DC power factor, there is no term like power factor, no term. First, I will tell you what is the formula of power factor. There are many formulas of power factor. One of the famous formulas I will tell: the active power upon apparent. The active power upon the apparent power. This is the formula for power factor. Okay. Well, one of our video, I have also made video on power factor. I have covered many details of power factor in that video. If you go through that video, that made one video, can capacitor reduce your electricity bill? Can capacitor reduce your electricity bill? There I have very in detail. I have covered this topic in detail. What is this power factor? What is this active power? What is this apparent power? What is reactive power? So everything I have covered in I will drop a link of this video into the description box. You can easily go through that video and you can see the concept of this. Okay, for here I would like to tell you the formula of power factor, that is your active power upon apparent power. This is one formula. I would discuss some other formula here that I have not covered in that video. That is R by Z. Do you know what is this R? Do you know what is this R? R stands for resistance of your circuit and Z is for impedance. Do you know what load that you are consuming? What type of load you have at your home? This load is nothing but RL type of load. RL. Actually loads are different. R type of load is there, L type of load is there, RLC load is also there, but C is very rare. Okay, C is that for capacitance. RL load that you are having at your home. Do you know how the Z comes? Impedance. Impedance means it is one of the quantity that is relevant to your load. So the formula of the Z is square root of R square, resistance square, and XL, the reactance square. How this XL is formed, you know? XL is nothing but 2 pi FL. F is nothing but your frequency and L is nothing but your inductance. Do you know what is inductance? Inductance is, it is one form of load. Like in layman language, I will tell you, if there are windings in your load, like in your fan or in your motor, if there are windings, then there would be inductance, right? So in your layman language, you can understand this. For your home life, it's I think enough for your home use. Okay, we will cover the inductance in detail in some other video, but not this. Okay. So this is how it is coming. For AC, there is inductance, there is frequency. Okay, inductance is also for DC, but see, frequency is not here, 0. That is why XL is 0 for DC, and for AC it is having some value. Okay, so this is now I think clear. Now let me tell you, the cos phi or cos theta is R by Z. Cos phi is your power factor, that is R by Z. See here, the cos phi is R by Z. This is actually coming 1. Mathematically it is 1 for DC, and it is having some value around 0.9 for AC. What is this power factor now? Power factor is nothing but it is actually, I would like to tell you very simple thing in power factor. I am not going into the mathematical formulas. I know you will not going to remember that. Power factor is nothing but the quality of power is consumed by your appliance, the active power quality consumed by your appliance. I will show you one example. If this is a beer box or beer glass or your soda glass or your thumbs up or Pepsi glass. So when you are filling it up, there are forms. Okay, there is a form and there is a actual quantity of liquid. This is liquid and this is form. So this liquid is nothing but your active power and this is form is nothing but your reactive power. Active power is what is actually consumed by your appliances, and reactive power, this is your magnetizing power or some other form of power, the power that is distorted ultimately. Like in your electronic circuits, the power is getting distorted, some form of power. There are harmonics as well. So that power is considered into the reactive power category, and reactive power, that is your actual consumption. Okay. So cos phi is coming from that only. If you want to understand it more detail, I will also show you the graph. See, if this is your voltage and this is your current, the angle in between this, that is your phi, and the cosine of this angle, it is your power factor. Why this angle is created, now I tell you. I already showed you the graph of voltage and current. This is your voltage, and if I am also going to consider this current here, if voltage is starting from here, then current is not going to start from here. Current is going to start from here. This is actually a general waveform. So this, this is the delay. The delay is described in term of power factor. So the delay described in term of power factor. So this is nothing actually. This is your angle, and this is angle is cosine of this angle, and the cosine of the angle is indicated as power factor. The angle between the voltage and current, the delay between the voltage and current. So mathematically it is described by this phi angle, and cosine of the phi angle is nothing but your power factor. Actually, if your current is rising from, if your voltage is rising from here, the current is giving you some delay. Why this current gives you some delay? Due to inductance. Do you know the property of inductance? It is opposing the sudden, change of current. If you are supplying your inductive load, then it is not going to allow the variation of current instantly. It is going to take some time, and that time taken, it developing one new quantity, that is power factor. In resistance it doesn't happen. Resistance does not resist any flow of current, or it does not resist any sudden change of current. So resistance, that is why in resistance, if you see, it is unity. For resistive load, the power factor is unity or 1. I hope the concepts are clear to you now. We have covered what we have covered. See what we have covered. We are going to summarize this. We started with the AC and DC, the supply that is coming at your home, 230 volt, 50 hertz. That is your AC supply. The DC that is coming from a charger. The AC we have covered. What are the appliances? I have also showed you the appliances, their rating, details, what things, what details are covered of AC. Then I showed you the DC, the what is the DC, why battery DCs are there, what is the waveform, why this is called DC, why this is called AC. Then I showed you why we are using AC, why not we use the DC, why we are using AC, what are the advantages, like what are the for stepping up the voltage, whether we can do it on a DC or not, why what are the disadvantage of DC. Everything we have covered. I hope the video is now clear to you. The query that you had of AC and DC is now being clear to you. Your doubt is absolutely clear now. So let's end up this video here. Let's meet you again in some other video. If you like the video, then just click on the like button and just don't forget to subscribe us. Thank you so much. Let's meet you again.